So besides the built-in functions, like length, len and max and min and sum and everything, okay, sometimes we may want to do some computation that's not available as a function, built-in function in Python. Okay. If it is not there as one of the built-in functions, then we can write our own function. So that's called user-defined functions. Okay. So built-in functions, so part of Python language, like print, range, type, and all that kind of stuff. Now, user-defined functions are defined by users to make calculations. Then, okay, that once you define it, then that function is now available to you as though it is one of the built-in functions. You can use it in any cell after that. Once you run a cell that contains the code of a user-defined function, then that function is from that point onwards is available to you. You can use it anywhere you want. Okay, and the syntax is start with def, okay, and then the name of the function. Okay, it's not showing up here. Let me see whether I have to figure this out. If I have just one slash, nothing shows up. If I put two slashes, it gives me what I need, but it also gives me the slash. I don't know. I'll have to figure that out. So there is no, you don't need a slash. Okay, def, the name of the function. Okay, and actually, it's okay. Let me do this way. Okay. Yeah. Okay. So if you're not going to send in any values into the function, you just have left and right parentheses. That's it. Nothing. You don't need to specify variables. But if you want to send some values to the user-defined function, then you'll have that. And then you have code block where you do the computation, and then you'll have return. Okay, you can have several returns in the code. Okay, you can have one return in one place and you can have another return. Okay, and you can return more than one value back. Okay, so here is an example. Okay, so here I start with def. Okay, def is how you start your user-defined function, right? And then I give a name. So def, and then you have my f1. So my function one. So this is the name of the function, and then we are defining the function, and therefore we can give any name we want. Okay, of course, you want to give a name that is descriptive of what is being done in the function. Okay, so my function is not a good name. Okay, but this is just an example. You give a name that is kind of descriptive of what is being done. Okay, now I have three variables here: x, y, and z. And for z, I have a default value. Okay, it's optional. You don't have to have. So what will happen is, if you do not send a third value to the function, then the function will assume that it is the default value 1.5. Z will be set to 1.5 if you don't send anything, if you send only two values. But if you send three values, then it will just ignore 1.5 and use the value that you send. Okay. So then here is a code. This is just, I have if z is greater than 1, return z times x plus y, otherwise z divided by x plus y. Okay. So that's my function. I run this. Okay. So now my underscore f1 is available, and it takes three values, okay, of which two are required. The third one is optional. If you don't give a third value, then the function will assume that the third value is 1.5. If you do give a value, then that value will be taken. So here I am sending 3 values. Okay. So my F1, 5, 6. Well, I don't really need to do z equal to, just 0.7 would do too. Okay. So 5 goes into x, 6 goes into y, and 0.7 goes into z. Okay. And then the computation is performed. Now here in this example, in the next one, okay, once you define, it's available to be used. Here I'm providing only 2 numbers, 6 and 4. So 1.5 is the default value for z. So z will be set to 1.5. Okay, all right. You can also return. Okay, so in the previous example, we did just say return. Okay. We didn't specify a variable name. Instead, we specified a computation. So that computation is performed, and that one value that comes out of that computation is returned back. But if you want to return more than one value, then obviously you have to put them in a variable, and then you can just say that I want to return those values. Okay. So here, this is a silly function. It just takes in 3 values and returns them back as it is. So we have a equal to 5. So I'm not getting anything from the call. So this function is always going to return 5, 6, and 7 as 3 values. So when I run, it's going to come back with 3 different values, and if I set them like this, like in the tuple case, so you get 5, 6, and 7 into A, B, and C. Okay? Any questions? Then there is lambda function. Lambda function, we talked about lambda function briefly before, and sometimes it can be confusing. Lambda functions are used very frequently, so it's not lambda. It's a one line. It's also called anonymous functions because you don't have a name for it. See, when you define your own function, say DEF, and you give a function name, and then if it takes any input, then you give the variable names of the input, right? Now, lambda functions do not have a name, okay, so it's called anonymous function. Okay. You can save a lambda function into an object name. That you could do, but you don't have to. Okay. You can use lambda function in our list comprehension. So you have the for loop and all that, and then the mathematical computation can be a lambda function, okay, where you don't have to have a name. So now I'm saying there are the lambda function takes in 2 values. So this is the input into the lambda, and then the output is a plus b. Now this lambda function takes in 4 values, and a times b plus c times d. So I'm saving it for the purpose of illustration. I'm saving it into the whole lambda is saved into an object, lam1 and lam2. And for lam1, if I give 2 numbers, then that operation will be performed. So I'm giving 5, 6, so you get 11, and here I'm giving 4 numbers. So 1 times 2, and then That's 2, 12, and you get 14. Okay. All right. So we have function, user-defined function, and then we have lambda function is also user-defined function, but it is an anonymous function. You don't have a name for it. And then a function that goes with user-defined functions, or any function for that matter, is map. So what map does is it maps the function over an iterable. So you define a function and you want to apply that function to all the values in the collection. Come on, man. Very distracting when I'm standing here and you guys are going on and on and on having fun. Having fun is good, yeah. I know it's really nice. But it is distracting. Take it outside or don't distract me. Okay? Thank you. All right, map function, what map function does is, okay, this should be a regular function. It can be a user-defined function, or it can be a Python function, built-in function. And then you give an iterable. So that function will be applied to each element in the iterable. So iterable can be a list or a dictionary or set or whatever. Okay. So here I have a user-defined function which finds the reciprocal of the value that we supply. Okay. So it's going to first test is x equal to 0. So comparison operator is two equal signs. Okay. Then if that is so, then you return nothing. So nothing comes back. That none is not a value. It is not a string. It just returns nothing. Okay. Otherwise, it returns 1 over x. So now we define that function. Once that function is defined, so suppose we have a tuple here, 11, minus 2, 0, and 4. Okay. And when I use map of that function name on this iterable, then the function is applied to each element in the iterable. So it's going to give you the operation map. But one thing we have to remember is the map returns back a map object. So the map object must be converted. So the result of the mapped function is returned as a map object. So if you simply print it, you're not going to see anything. You're going to just see map. Okay. So you have to then convert it back from map to what you want. So, all right. So when I try to print RESP underscore result, I have map. So mapping occurs, the calculation has not occurred yet. Okay. Only when you open up the map object, the computations are done and you're given the values back. So if I can take that and convert it into a tuple. Okay. So now the map object is gone now. Okay, that's all of the content of the map object is being taken out. So if I try to use it again, so if I run it, okay, if I run it again, I get nothing because the resp underscore result, the map object has been used up. So there is nothing there. And now you do a tuple of that again, so you get nothing back. So you must remember that. So tuple or if I want it as a list, I can do, of course, we have to run the map function one more time, otherwise you get nothing, because the map function, once it is mapped, once you do the unmapping, okay, once you convert the map into a list or something else, the map function itself will become nothing then. Okay. All right. So your turn now. So write a function